All right, sorry I can't be there in person. My job here today is to share background on the emerging intensification technology in aquaculture, from split ponds to recirculating systems. So let's see what we can do here. Um, so I'm getting more and more questions from Missouri farmers, Midwestern farmers. They know about aquaculture, and so they're asking, could this technology expand their farm production and their income? Everybody knows this slide. Aquaculture production has emerged in the last uh, 30 years or so, contributing basically half of our seafood production now. Here's a quick table. One more thing to mention to you. A lot of slides here, a lot of numbers. So at the end of this presentation, I have a web link where you can gain access to this presentation. And I will post that in the chat section when we get done here. So aquaculture over the last 60 years, from the 60s to 2020, in the 1960s, people were growing around 1,000 to 2,000 pounds per acre. Typically, the pond production was wind aerated. Today, we're looking at 45,000 pounds per acre in these super intensive nitrifying heterotrophic systems that can be indoor or they can be outdoor systems. Let me talk a little bit about the different systems, indoor and outdoor. The key point here, or the starting point, was a partition aquaculture system that we developed back at Clemson University beginning in the late 80s and running into the middle 2000s. Basically, we transformed fish pond into raceway culture by putting in paddles and moving water. We were able to expand pond fish production from around 5,000 pounds per acre up to almost 20,000 pounds per acre. Mississippi, the guys over at Mississippi, in particular Craig Tucker at Stoneville, Mississippi, liked the PAS, but he said that, well, the PAS system is just too expensive. So Craig Tucker's comment was, partition aquaculture looks great, but it's too expensive for Mississippi fish farmers. So he came up with the Mississippi split pond. The Mississippi split pond was basically taking an existing watershed pond and putting a levee across it and crowding the fish up into one end in a production pond and the rest of the pond serving as a waste treatment site. Basically, this is what Craig Tucker referred to as his poor man partition aquaculture system. Also, at the same time at Stoneville, Les Torrens was putting huge amounts of aeration in existing ponds, claiming that he could match the production in a split pond by doing what he called intensively aerating pond production. By 2015, Craig Tucker had already expanded his split ponds into these relatively large systems where they could gather data and have some confidence as to the reliability of these techniques. Les Torrens continued with his intensive systems, putting 10 or more horsepower per acre into ponds. So just sharing some real quick conclusions. In partition aquaculture, we were growing fish in 5% of system area. 95% of the system was waste treatment. We used tilapia to control the algal populations in those systems, and so we had green algal dominance throughout the year. The guys over at Stoneville weren't willing to mess around putting tilapia in their ponds. So in the split ponds, they were crowding the fish up to about 28% of system area for production, and they were growing mainly cyanobacteria or blue-green algae. That's basically algae that winds up dominating these systems. Sedimentation in the waste treatment side was how the algae was being removed. The other thing was significantly different. They were getting a significant amount of nitrification in the split ponds. We never saw nitrification in the partition aquaculture system. In the intensive ponds, 8 horsepower per acre, aeration, typical, 100% of system volume. Fish are distributed throughout that water volume like a conventional pond. Again, rapidly growing cyanobacteria or blue-green algae is providing the water treatment. Pretty high algal cell densities. Conventional ponds, the big difference from conventional ponds, intensive ponds, and split ponds is that the algae are relatively slow growing. in conventional pond. That's the big difference in mixing water, either intensity pond, a split pond, or PAS. We increase the growth rate of the algae and provide the extra treatment, which provides the extra carrying capacity. And the big difference is conventional ponds around 2.5 horsepower per acre, whereas you're looking at 8 or even 10 horsepower per acre in these intensity ponds. Another system that the guys over at Auburn have spent a lot of time working on is the in-pond raceway. Jesse Chappell is the guy over there who's done most of this work. This is an in-pond fixed raceway. Basically, it's built, raceway is built on a slab in an existing watershed pond. This is their floating raceway, expensive operation, but the advantage of that is it can be used like a trailer and just backed into a watershed pond. They've had a fair amount of success with that over in Auburn, but here's the bottom line. Here's a recent publication by Dr. Kumar over Stoneville, Mississippi, looking at the cost. And here's the big deal over here on the side, the break-even cost. In other words, breaking even the cost of system, typical production systems, $1.32 a pound for the in-pond raceway versus essentially 92 to 93 cents a pound for the intensively aerated and the split pond systems. The intensively aerated ponds and split pond systems are basically going head to head in terms of being competitive with cost of production. If you look at overall production, around 7,500 to 20,000 pounds, 7,500 to 27,000 pounds per acre in split ponds or the intensity ponds. Typically around 5 to 7 acres for intensively aerated ponds, split ponds around 10 acres. This is the experience so far between the guys at Stoneville and the commercial producers in the Delta. And you're going to, here's a big difference. The intensively aerated ponds, they're putting as much as 10 horsepower per acre out there in those ponds. Now, remember, this is the South and this is catfish. So there's a big difference in these numbers if we start talking about Midwestern production. We don't have the degree days to grow fish in the Midwest that these guys have in the South. So that translates into longer grow out periods, which translates into higher cost per pound, anywhere between 1.5 to double the cost of southern catfish production. That's about as good as I can do because that's an estimate, because the truth is we don't have a lot of split pond and intensity ponds in the Midwest, so we don't really have a lot of data. And then the other problem is bass. Got to go back. Bass densities can't run at catfish densities typically. So that's another 1.5 to 2 in terms of cost. So if you look at this, if you're talking $1 a pound for catfish at typical southern grow out temperatures and densities, you double that to $2 for being in the Midwest at lower grow out temperatures, and double again for lower densities. You're already, you're real quick talking about $4 a pound. $3 to $4 a pound for bass in the Midwest and these outdoor systems because of the temperatures and the density requirements. So one of the things that I've done in the last 3 years here in Missouri, in Morgan County, you see Morgan County, University of Missouri is right here in Columbia. I'm 90 miles from the campus, and I've got a 120-acre farm down here in Morgan County on the edge of the Ozarks, so I got a lot of water flowing out of the ground. I've built a prototype zero discharge, temperature-controlled recirculating aquaculture system so that I could do a hands-on evaluation of the economics. So if you're going to do this, the first thing you got to do, if you've got a farm in the Ozarks, you got to make a flat spot, because farms in the Ozarks don't have flat spots. And so I spent $3,500 getting a flat spot to put up a building. And all right, next I got the local contractor to build me a building, insulated on a 4-inch slab, actually a 5-inch concrete slab on gravel. Cost me $120,000 to put up the building, another $10,000 plus the site preparation. So I spent $22.25 a square foot putting up a building to grow fish in. This is a Sukup building, 100 by 60 feet, 6,000 square feet on a concrete pad with gravel. I built a series of prototype raceways. I first of all, I had a contractor put in a water collection sump into that floor. He formed it into concrete, so I'd have a low spot for water to go. I built a series of what you might call carpenter's versions of prototype raceways to see what would be the best technique for putting water on a floor. One of the things I looked at is putting a 30 mil high density polyethylene liner and inserted into a 3/4 inch plywood containment for providing 2,800 gallons. The liner wasn't expensive. The plywood containment was expensive, and after COVID, this lumber prices went through the roof. It started out. It was actually initially I was around $1 a gallon, but when lumber prices skyrocketed, today we're looking at probably $1.75 a gallon. And I cannot recommend this liner. This liner is a pain. It's just they always leak. My experience, the manufacturers claim they don't leak. My experience, every one of them will always leak. Here's another way of doing it. 1/2 inch welded PVC sheet inserted into 3/4 inch plywood, $1.86 a gallon. This works really well. I figured out a better way to do it rather than weld. You can weld those edges. That's a pain. The easiest way is just cut a short scab, put PVC cement on it, and slap it on there. It takes a matter of minutes to do that, and it's absolutely watertight. I went ahead and invested in one of these German systems because I wanted to see it. This is a commercially available glass-coated steel raceway, anchor bolted to the concrete. It's cost a lot of money for 8,600 gallons. Worked up at $2.80, nearly $3 a gallon to put this thing up, with 50% of the cost being the massive labor required. This is a heavy thing. Shipping cost for this thing was greater than the cost of my other systems. Here's the system that turned out to be, in my opinion, a winner. This is a concrete-filled prefabricated PVC system. This one was 7,200 gallons. These PVC forms are lightweight. They're cheap, $3,000. They come on a pallet. They don't cost a lot to ship. And then the major weight and investment is getting your local concrete man here to back in the concrete truck and fill this thing with pea gravel sized concrete. So the end result is you get a PVC face on a concrete raceway. This worked out. I'm really sold on this. This is a company out of Canada that's producing these. They actually started making these for hog confinement buildings, but they're also now making them for aquaculture. This worked out to be less than $1 a gallon. And then, of course, you got to have all the supporting equipment. I'm using a rotary compressor, an oxygen separator, bead filter, blowers, ozone generators, and I built a separate machine room to get the noise out of the fish culture area. So all this noisy equipment winds up out here in this machine room. So all you hear inside the room is water bubbling. Of course, you got to have a water supply. So I invited in the local hillbilly well driller. He came out and did a great job. Put in a 25 GPM well. It cost me $6,600, another $4,000 in plumbing. I actually have two water sources. I have an artesian well at the bottom of the hill that I provide piping to, so I can use the local my drilled well, or I can use my artesian well as a backup source of water to my system. Just some quick numbers. I won't spend a lot of time on these, but if you download this, you'll be able to take a look at this. Bass runs around a 1/2 pound per gallon maximum. I did the economics both on bass and shrimp. Shrimp in a so-called autotrophic system, which means nitrifying system, and shrimp in a heterotrophic system, which means a biofloc sugar-fed system. These are the two primary systems that people are using to grow marine shrimp in indoor systems, trying to produce 22-gram shrimp or a jumbo-sized shrimp in roughly 90 to 120 days. So it's possible to get 3 to 4 crops of shrimp a year, depending on the system configuration. The difference is, though, with bass, because bass is a 3-dimensional animal, you put a lot more bass biomass on your concrete in a building than you do shrimp. but you get more crops with shrimp. 1 year or more time for bath, 90 to 120 days. And so that's the basic lowdown on the numbers. Here's what really matters. So looking at an indoor system, climate controlled, zero discharge, talking about 2 shrimp systems, we're talking around $9 a pound cost production or break even cost. And for bass, around $4.20 a pound. I compared these numbers to the numbers of commercial growers, and it looks like the numbers that I'm coming up with, my experience, seems to match the numbers that we're seeing from the commercial growers. So the big deal here, ponds versus RAS. First of all, recirculating aquaculture production costs cannot compete with southern U.S. pond production costs or seafood commodity costs. RAS production costs range between 1 to 6-fold over farm gate or dockside prices. But the good news here, if you look across this picture of pond versus RAS, break even, farm gate, wholesale, and retail, there's still a significant margin with respect to seafood prices. Retail seafood prices range from 45 to 65% of RAS production costs. So yeah, RAS cannot compete with pond, not by a long shot, but people are still willing to pay the money that would support RAS production costs if you can sell directly to the consumer. The downside is if you're selling to the middleman, you're probably going to be selling your fish at break-even prices because the middleman's got to have his profit margin, and it turns out that his profit margin is about the difference between what he pays you and what he gets from the retail market. So zero discharge controlled climate RAS production costs range from around $4 a pound for bass to around $9 a pound for shrimp. Production energy requirements are around 5 kilowatt hours a pound for fish to 15 kilowatt hours per pound for shrimp. But that's good if you compare it to the other animal production systems. Chicken, pork, or beef is substantially higher than fish or shrimp. Profitability of the zero discharge RAS systems is most likely going to require retail sales. So for everybody that wants to jump into this, you need to think about this. If you're a grower and you're going retail, that means you got to bear the cost of seafood holding, processing, transportation, package, advertising, market to sell your product directly to consumers. My advice, begin small, consider markets before addressing technology and investment. Which species, what product to provide, whole or processed, and where to sell. This is I'm going to copy this web address and I'm going to post it here on the chat section where you can have it to take a look at. And one last thing before I leave, since we're talking about producing fingerlings, someone's going to ask me, did you ever try to produce fingerlings in the PAS? And the answer is yes, we did. And here it is. We configured the PAS into cells where we could pour water and feed over the small fish. And what did we find? We found that when it was all said and done in a PAS cell, we could produce an 80 to 100 gram fingerling as opposed to a 30 to 40 gram fingerling that we're getting out of ponds. Craig Tucker, when I told him this, I showed him the pictures. He said, "That's not a fingerling, that's a fish." So we had a lot of luck growing fingerlings in the PAS.